Hi and welcome to another chemistry lesson. In this lesson we're looking at types of bonds still. We looked at covalent and ionic bonds in the previous video, so if you didn't get that one I encourage you to go and look at that one. But now we're going to look at metallic bonding. Now metallic bonding is different from covalent and ionic bonding, but almost like a combination of the two, but it specifically refers to the way in which metals react with one another. So if we look at the metals, which are all of these first groups, they can react within themselves. So for example, zinc atoms can react with other zinc atoms to produce a metallic bond. Okay, and it's not the same as covalent bonds where hydrogen had to share one of his valence electrons with one other hydrogen valence electron. Here they do share it, but they share it in a sea of electrons. Okay, let me show you what I mean. So imagine we had a zinc element. Now the metals, this transition metals, work a little bit different with the way that the electron structure work, which falls outside of the scope. But all you need to know is that zinc itself has two valence electrons that he will donate. Okay, and another zinc has another two that he will donate, and another zinc will have another two that he will donate, and all of the zincs together will donate their electrons into a sea of electrons that flows around the ions that are left behind. So remember, if I donate 2 electrons, I become a positive charge. Okay, and since I donated 2, I've got a 2 positive charge. 2 positive. So I've got all of these cations floating in a sea of electrons. Now an electron itself is an anion, a negative charged particle. So I've got all of these positive charged cations floating in a sea of electron anions, and the particle, the cations, are attracted by the sea itself. Okay, so they are stuck in this sea of electrons that move freely around. Now this is what gives metal its properties. All metals have certain properties, and depending on the strength between this the cations and the sea of electrons, okay, that will depend on how strong these properties are. One of the properties, for example, is the fact that it's very strong. Okay, there's a very strong attractive force between these many ions and the sea of electrons. Okay, so it's very strong. The other one is we can bend it. It can be bended. Now if you can imagine this sea of atoms together, I don't know, but I've got this intuitive feel that this is very pliable, it's bendable. The correct term is ductility. Ductility is the ability, or how far you can stretch something until it breaks. Okay, and we know, well, if you've worked with any sort of metal or wire, you know that you can bend metal. Okay, that's the one thing. The other one that is easy to understand is electricity. It can conduct electricity. I think I spelled that wrong. Is that an S? I don't know. Okay. Electricity. Why can it conduct electricity? Well, electricity is a flow of electrons. That's what electricity is. It's electrons flowing. And we already have a sea of electrons, and these electrons are glad to flow around, and so they very easily can move from one place to another place, causing a current and a flow of electrons. Okay, so electricity can be conducted. It also conducts all energy. It can conduct energy very well. Now energy in atoms are carried by the motion of the particles in the atom. So for example, the faster this electron moves, the more energy it has. Okay, so if I am applying some sort of heat on this side, I'm exciting the electron. That electron starts moving more frantically, and because he's in a sea of electrons, he can move very easily to a place around here and excite the other electrons as well as it's bumping into them. I don't know if that really happens, but point being, it's very easy for this electron with his energy to get to another place in the metal, in the solid metal, or even different states, and therefore carry energy to another point, which means it's conducting energy. Now, I don't have anything more to tell you about metallic bonds. It's a very simple concept. It happens when metals react with, it could be with other metals, but primarily within themselves, in order by sharing their electrons in a sea of electrons, and therefore creating cations, which is attracted to this sea of electrons that's being shared. I hope that made sense to you and that you learned something in this lesson. I'll see you in the next one. Goodbye.